Today we are going to discuss nanoscience and technology. What is nano? Nano is very, very small. That is 1 billionth of something or 10 raised to minus 9. And nanoscience, the study of structures and unique properties of matter at the nanoscale is called nanoscience. And nanotechnology, the design, characterization, production, and application of structures, devices, and systems by controlled manipulation of size and shape at the nanometer scale is called nanotechnology. Surface to volume ratio. Materials in nanoform have relative larger surface area when compared to the same volume of the material. For example, consider a sphere of radius r. We know that the surface area is 4 pi r square and the volume is 4 by 3 pi r cube. Surface area to volume ratio is 3 by r. That is, the surface area to volume ratio increases with the decrease in radius of the sphere and vice versa. When the given volume is divided into smaller pieces, the surface area increases. That is, first we consider a cube of side 1 meter. We know that the surface area is 6 into 1 meter square, that is 6 meters square. If we divide the cube into 8 small cubes of side half meter, then the surface area is 6 into half meter into 8. That is, the surface area is 12 meters square. So, the particle size decreases, greater portion of the atoms are found at the surface compared to those inside. That is, when the given volume is divided into smaller pieces, the surface area increases. That is, the particle size decreases, a greater portion of the atoms are found at the surface compared to those inside. That is, nanoparticles have a much greater surface area per unit volume compared with the larger particles. It leads to nanoparticles more chemically reactive. And the next is quantum confinement. The phenomenon of the non-zero lowest energy and quantization of the allowed energy levels arising from the confinement of electrons within a limited space. The physical properties of semiconducting nanostructures arise from quantum confinement. We have already discussed Schrodinger's equation in quantum mechanics gives energy E equal to n square h square by 8 ml square, and the minimum energy is non-zero, that is E1. E1 equal to h square divided by 8 ml square. Thus, the quantum confinement leads to non-zero lowest energy and quantized higher energy values. That is quantum confinement. And nanostructures. The materials which have at least one dimension in the order of nanometer are called nanostructured materials. Based on the size and shape, the nanostructures are classified into three-dimensional materials, two-dimensional materials, one-dimensional materials, and zero-dimensional materials. So, three-dimensional materials. Materials that are not confined to the nanoscale in any dimension. That is, here all the dimensions are above 100 nanometers. So, for three-dimensional materials, the electrons are fully delocalized. That is, the electrons have no specific location. They can go back and forth between one location to another. So, this is three-dimensional materials or zero-dimensional confinement. Here, the electrons are fully delocalized. Three-dimensional materials or zero-dimensional confinement. And the second one is two-dimensional materials. Here, at least one out of the three dimensions is in nanometers. In this case, the conduction electrons will be confined across the thickness but delocalized in the plane of sheet. That is, two-dimensional materials or one-dimensional confinement. Here the electrons are confined in one dimension and delocalized in two-dimensional. So this is known as two-dimensional materials or one-dimensional confinement. Quantum well is the example for this. Here, the trapped electrons feel like a particle in potential well. And the third one is one-dimensional materials. Here, any two dimensions are measured in nanoscale. For example, nanowires, nanotubes. That is, here the electrons are free to move only in one direction, or in other words, the confinement occurs in two dimensions. That is, one-dimensional materials or two-dimensional confinement. Here the electron confinement in two dimension where the delocalization takes place along the axis of the nanowire. That is delocalization in one dimension and confinement in two dimension. That is one-dimensional materials or two-dimensional confinement. Carbon nanotubes are example. Then zero-dimensional. Here, all the dimensions are at the nanoscale. That is, an electron is confined in three-dimensional space. So, the electrons are not free to move at all. That is zero-dimensional material or three-dimensional confinement. So, quantum dot are generally composed of atoms and between atoms from the group second B to fourth. So quantum dot is the example for zero-dimensional or three-dimensional confinement. So this is quantum dot and quantum wire and quantum well. So quantum dot is three-dimensional confinement or zero-dimensional nanostructures or material. And quantum wire, this is two-dimensional confinement or one-dimensional nanostructures or material. And quantum well, this is one-dimensional confinement or two-dimensional nanostructures or materials. So this is quantum well or nanosheet. Here, one-dimensional confinement and two-dimensional material. Here, the electrons can move freely in the plane of the layer but are restricted to move in the perpendicular direction. That is, here one-dimensional confinement, and the electrons are free to move in two dimensions, that is along the plane of the layer. But the electron movement is confined in the perpendicular direction, that is one-dimensional confinement. This is quantum well. And quantum wires, here two-dimensional confinement or one-dimensional material. Here the electrons are free to move along one-dimensional structures, that is one-dimensional material, and the confinement along two dimensions. So along this part, the electrons are confined, and or along the two dimensions, the electrons are confined, and one dimensions, the electrons are free. So this is known as one-dimensional material or two-dimensional confinement. And quantum dot is three-dimensional confinement or zero-dimensional material. That is, here three-dimensional quantum confinement structures. Here the electrons are not free to move in any direction. That is zero-dimensional material or three-dimensional confinement. Here the electrons are confined in all the three dimensions. That is quantum dot. quantum wire. Quantum wire is two-dimensional confinement or one-dimensional material. That is, the electrons are free to move along one dimension and the electrons are confined in two dimension. And quantum well or nanosheet. This is one-dimensional confinement or two-dimensional materials. That is, the electrons are free to move two dimensions and confined along one dimension. That is quantum well. So that's all.